section 1.4, where we're going to look at solving what are called quadratic equations. We saw these in college algebra, and now you're seeing them again. Now, just to take a look at this, we've got a problem here. We've got something like, you've seen it plenty of times before, like this: 3x plus 2 equals 7x minus 12. Remember, the goal for something like this is to get x by itself. And that's because we only have an x to the first power. It means we're only going to get one solution for x. If we get one at all, we'll get x equals some number. So you get x by itself. But it's because the highest exponent on x is just a 1. And this is called a linear equation college exponent is to the first power. However, in college algebra, college algebra and intermediate algebra, you start looking at things that have a squared as the highest exponent. This is when you're starting to look at things that are called a quadratic equation. And with quadratic equations, we have the highest exponent being squared. That's the difference. And the goal with a quadratic equation is we want actually the reverse. We don't want to get x by itself. We want everything on one side and 0 on the other. So we want everything on one side and the other side to be 0. So we want everything on one side, and then we want 0 on the other side. And when you learn how to do this originally, the goal is so that when you get everything on one side, then you can factor, so that then you'll have something factored that also still equals 0. And remember, once it's factored and equals 0, either the first thing has to be 0 or the second thing has to be 0. So what you learn to do is you set each piece equal to 0. And what you end up doing is you end up solving two smaller equations set equal to 0. And instead of getting one solution for x, you end up getting usually 2. So you get x equals probably 2 numbers, and that's because your exponent is squared in a quadratic. Now, you might get the same answer twice, but you're still technically getting 2 answers. So let's go ahead and go over this and kind of do reminders of how this works. So in this first example, in A, notice we've got an equation. It says to solve, and if you were to kind of see what is going on here, and you don't want to multiply this out, but just to show you that if you were to try, the first thing you'd get is an x squared, which means you are going to end up with 2 answers. However, we don't want to multiply this out because it's actually set up perfectly. It already equals 0, and on the other side, they already did the hard part. They already did the factoring. Once it's already factored and equal to 0, remember then from college algebra that we set each piece equal to 0. So we'll set the x plus 3 equal to 0 and the x minus 7 equal to 0 and solve those two smaller equations that are much easier. The first one will subtract 3 from both sides, and that will get us an x equals -3. And on the second one, we'll add 7 to both sides, and that'll give us an x equals 7. And those are our 2 solutions for x. Now let's take a look at B. In B, we've got x squared plus 3x minus 18. It does already equal 0, which is half of the problem. So it does already equal 0. The problem is this time it has not been factored yet. So we need to factor this. Remember, back from college algebra and intermediate algebra, or whatever class you learned how to factor in, is we want 2 factors of, let's see, negative 18 that add up to a positive 3. Well, two factors of negative 18 that add up to a positive 3 are a positive 6 and a negative 3. And remember, we just bring down our x's. So then we set both equal to 0 again once it's factored. So we'll set the x plus 6 equal to 0 and the x minus 3 equal to 0 for our two answers. And on the first one, we'll subtract 6 from both sides and we'll end up with a negative 6. And on the next one, we'll add 3 to both sides and get a positive 3, but we do get two answers, negative 6 and positive 3. Let's take a look at problem C. And in problem C, we've got, let's see, x squared minus 15 equals negative 2x. So the problem with this one is we don't even equal 0 yet, so we would need to move the negative 2x to the other side by doing the opposite. We'll add a 2x to the other side. So that'll get rid of the 2x, and it will leave us with an x squared plus 2x minus 15 now equals 0. Now we can do our factoring. So now that it equals 0, we can do our factoring. So let's see. We need now, let's see, and it does equal 0. So we need two factors of negative 15 that add up to a positive 2. Well, two factors of a negative 15 that add up to a positive 2 is a positive 5 and a negative 3. Again, bring down your x's. Well, then we do the same thing as before. We set both pieces equal to 0 once it's factored. So set the x plus 5 equal to 0 and the x minus 3 equal to 0. And that will give you two answers. On the first one, subtracting 5 from both sides gets you a negative 5. And on the second one, adding 3 gets you a positive 3. And those are your two solutions, negative 5 and positive 3. In problem D, we've got 3x squared minus 2x equals 0. It does equal 0 already. This is not going to be the same type of factoring, however, it is still factoring. People forget the most common and easiest way to factor is to pull out what they have in common. Well, notice both pieces have an x, so I can factor out an x. It's called a greatest common factor. And we still will equal 0, which will leave us, if we factor out an x from both pieces, will still leave us with a 3x and a minus 2. You still do the same thing. We have two things set equal to 0, so I have to set both of them equal to 0. So I start out with my x and set that equal to 0 first. It's just that that's already solved and equal to 0. My second piece, my 3x minus 2, setting that equal to 0 is a little bit more complicated. Not bad. What I can do, though, to solve that is add the 2 to both sides first, and then divide by 3, which will give me 2/3. And that's my final answer. Now, there are other ways to do these same type of problems. It just depends on the setup. So if we have something like, let's say, ax squared plus bx plus c equals 0, the quickest way is to just make sure that it equals 0 and a factor. However, if there is no middle term, no x term, and we just have something squared, we can do something special. Then you can instead get the squared by itself and get rid of the squared. So once you have the squared by itself, you'll have something squared equals some number. And you'll say, well, how do I get rid of something that's squared? You'll do the opposite. You'll take the square root of both sides, but there is a catch. Whenever you take the square root of both sides of an equation, you have a huge catch that you need to pick up a plus or minus symbol. And that's why on this part you see a positive answer and a negative answer, because you should be getting both a positive and a negative. So why is that? Because you had a squared, you should be getting 2 answers. So you get x equals plus or minus the square root of whatever number you had. Notice this will only happen when you take the square root of both sides, and it's because you should be getting 2 answers. This trick only works if you only have something squared, and it's called the square root method. And it only works when you don't have that middle term. So let's take a look at a couple examples. Let's take a look at problem A. In problem A, we have, let's see, an x squared equals 81. So the squared is already by itself, so you can go ahead and just jump to getting rid of it. We don't have any other pieces. So to get rid of just a squared by itself, you can take the square root of both sides. But remember, the catch is you have to pick up a plus or minus symbol. Well, on the left-hand side, the reason why this works is the squared and the square root are opposites. They cancel out, leaving you with just the x. However, on the other side, I had a plus or minus. And then I also had a square root of 81. Well, the square root of 81 is just a 9. So what this means is I'm getting 2 answers. I'm getting positive 9 and negative 9. And remember, I should be getting 2 answers because my original problem is squared. Well, will I always get 2 answers? Yes. Will they always be nice like this? No. And sometimes you'll get the same answer twice. Here's another one. We've got x squared equals 32. So again, the squared is already by itself, so you'd start off by taking the square root of both sides. And don't forget your plus or minus symbol. Just like before, the square root and the squared are opposite, so they cancel each other out, leaving you with just the x. We still have our plus or minus, so that we end up with 2 answers in front of our square root. But we have the square root of 32. There's a problem with this answer, is that the square root of 32 can be reduced or broken down. Is 32 can get broken down into 16 times 2. Why is that helpful? So we get x equals plus or minus 32, square root of plus or minus 32, and we've got the 16 times 2 we can replace that with. The reason why that's helpful and what you learn in all algebra courses is then the reason why you want to do this is because you can take the square root of 16. The square root of 16 is what? It's 4. So we can pull a 4 out of our square root. So we've still got our plus or minus, but now we can take the square root of 16. It will come out as a 4. However, you can't take the square root of 2 at all, so that would have to stay inside. So as a reminder, you still need to reduce your square roots like you learned to before in the past. That has not changed. If you can break off something that you can take the square root of, you want to. Notice you do get 2 answers. You get 4 square roots of 2. That's your positive answer, is positive 4 square roots of 2. But you also get a negative 4 square roots of 2. 2 answers.